All right.
Hey,
Thanks,
so
everybody.
yeah,
You
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 go on, Jamie. Then we'll
got some.
introduce ourselves.
Yeah, go ahead. You got some words. You start.
So yeah, thank you everybody for joining our commercial training session. I'm Antonia. I'm the North American marketing manager and the Canadian sales manager. And Jamie here is, I'll let you introduce yourself.
Eastern Regional Sales Manager for the United States, and it's pretty much encompasses the Eastern Time Zone. So,
Yeah, so for anybody that has got questions or comments throughout, feel free to unmute yourself and interrupt us, or you can send in a Q&A or something on the chat box and we'll pick that up as we're going. And Jamie, I don't know if you want to give a little bit of background on yourself before you start.
sure, yeah, okay. Started in the industry back with Johnson Controls in 2000, quoting control systems for the limited group, which would be the Gap, Banana Republic, I guess the Limited, and Old Navy. That worked into a job with a European boiler manufacturer where we were the distributor throughout North America. And they were French made, worked for them for about 6 years and saw a lot of issues with water quality. And that's kind of where it started. I'm old enough to remember when outdoor reset was new and primary, secondary piping was new and kind of foreign to everybody. So it's all part of the lexicon these days. But after working for the boiler manufacturer, I worked for a couple rep firms in New England. Worked for Viga, that everyone's probably familiar with, the Pro Press, and here I am at 80. Full circle, back in boilers and hydronics. So I love it. Getting out of the plumbing stuff is not that I hate plumbing, but this is much more exciting. So this is pretty much the presentation that we did at AHR, which was, we were bound by about 20-25 minutes. So it's going to be a quick one. It's real high level views of things. So like Antonia said, if you got a question, just shout it out and we'll try to answer it for you. And this is where we start. These are the simple objectives, we call them. The expectations, really. When somebody purchases equipment for their mechanical room, they want it to perform as advertised, last as long as it can, and do it efficiently. I think the same goes for the specifying engineer, the installing contractor, and most importantly, the end user or the building owner. And here's why. Because energy usage in commercial buildings, and this is old data, keep in mind, this is from 2011. So energy costs have skyrocketed since then. I would argue that it's more than 59%, but we'll stick with this figure anyway. For HVAC, heating, hot water, air conditioning, you can see the little pieces of the pie chart there. Catering, I still want to know what company this is because I'm waiting for my lunch right now and it's not here, but 10% for catering, good for them. But this is why it's very important for filtration and water treatment. It's really essential to keep it extending for a longer period of time, running efficiently, like we said. And we talk system efficiencies, not just the big engine, the boiler, or the chiller. We want the pumps, the zone valves. We want to make sure the building management system is getting the right readings in order to adjust set points and that sort of thing, and also reduce maintenance cost, right? And the newest thing that's come into our industry, I guess it's been about 10 years now, is the net zero stuff. So we want to lower our carbon emissions as well. But something to point out on this slide are those two little red circles in the bottom down here, where it talks about scale and biofilm. And I was aware of the scale issue, 1.6 millimeters of scale causing that 10 to 12% in loss in heat transfer. But the biofilm was shocking to me. 1 millimeter is a 50% loss in heat transfer. So we're going to touch on that a little bit. Let me move to the next slide. So every commercial system is unique and different. And I like keeping this picture of London up here because we are a UK-based company. And it's fun to name these buildings, right? That's the Shard and the cheese grater and the pickle. And if you've never been there, that's the Tower right there, London Tower, where all those heads got chopped off, and Tower Bridge. So old buildings, new buildings, it's quite a cross section of a big metropolitan area with different HVAC systems in them. And just to prove the point here, these are 3 different schools in that London area, each with different issues going on with their water. You can see the different colors there. So we'll touch on one of these systems later on in the presentation, but this is just to hammer home the point that you can't use a cookie cutter approach when it comes to HVAC systems. You really have to look at them individually. So the root causes of commercial system issues, corrosion is our big thing. That's the one we'll be talking about the most. And some of the problems caused by corrosion are listed there. We'll touch on them a little bit later. But there's also debris and sedimentation, which is a result of corrosion a lot of time. Can also be when everything was installed. You could have solder, rubber, kind of stuff if it wasn't properly purged and flushed before it was started up. And then bacterial. Again, touching on that 50% loss in heat transfer. I look at hydronic systems just like I do the human body, and they can get infected too. And there's nutrients in there, there's oxygen. Some of these bacteria are, excuse me, some of these bacteria are anaerobic, so they don't need the oxygen in order to cause problems in the system. But it is an issue, and you'll see why later on. Scale's the final one. We'll touch on this one first off, because it's a problem for pretty much 85% of the country. You can see here, and don't yell at me, Canadian boys, we don't have the Canadian map here, but I think what is it? 90% of the population lives within 100 miles of the US border anyway. So I think you can kind of translate and draw those pictures up further, and you got a scale problem too.
Yeah, it's very hard in the prairie provinces. Ontario, there's definitely very hard areas. I'd say closer to Vancouver, it's pretty, soft there, but as you start to, get north, and it gets harder. So
this is one in the backyard here for me, where I grew up in Ohio. I'm in New England now, but this is a university down in the tri-state area there of Indiana, Kentucky, and Ohio. I'm not going to throw them under the bus and tell you who it was, because this is what their fire tube boiler looked like. They showed me a cutout section of it, and they had pallets of Ridline in that building. And I hated to tell the guy, I wish I was selling him Ridline, because they're not doing anything for him. It doesn't look like it. I don't know how much heat transfer they're getting there. 1.6 millimeters is 12% loss. That's over 100% heat loss if you go by that figure. But I thought that was interesting when that guy brought that out to me. So I wanted to keep it. He wouldn't let me. So pictures is all I have. So to touch on the bacteria, it's a big problem in closed systems, and particularly during those shoulder seasons where you're switching from heating to cooling, especially if they're sharing system water, like a 2-pipe boiler chiller system. And again, I think of COVID and all those office buildings that were closed down. You start looking at slow moving stagnant water and system dead legs. There's tons of buildings out there that are just starting to open up, and these issues have probably been going on. They've probably just been idling to keep from freezing, and that's a perfect recipe for bacterial growth. And 90% of bacteria exists in complex biofilms. And I was doing a little research yesterday, again, just comparing things to the human body. You think about bacteria that's resistant to antibodies. There's a lot of them out there, and it has a lot to do with the biofilms that they create within your body. So just like the human body, bacteria biofilms are 3 times more resistant to biocides, and they can also cause problems with your inhibitors not being fully effective if you have biocides and a biofilm in there. We talked about the reduced heat transfer already. And the other thing, blockage of valves and strainers and that sort of stuff. So that's a big issue with the growth of renewables and low temperature air or ground source heat pumps. It's going to become more of an issue. So I think we're going to see this popping up, and hopefully we can sell the right product to get the people with those issues out of that problem. And corrosion, that's the one we like to talk about. It's driven by the amount of oxygen that's in the system. And generally, when you have a single material, like they're showing steel pipe here, it looks like Sked 40, you get corrosion across the whole surface. So it's not just spotty. Once the corrosion starts, it's affecting the whole surface of the pipe work there. And these are the factors affecting it. Oxygen being the number one, and sedimentary debris, whether it's in there from the installation or as a result of corrosion that's already happening. Bacteria, we talked about. System pH, tied in a lot with the degradation of glycol. You can start getting a pH out of range that we look for 6 to 8 is the sweet spot, right? And then, well, what do you say? 7 to 8?
6, well, yeah, 6.5 to 8.
Yeah, okay. A 6 to 8. I like using round numbers, Antonia, so I'm going to stick with that. But the other one you don't think about is the galvanic potential, which is galvanic corrosion, those mixed metals in the system. I did a presentation yesterday. If you guys got on here later, I had a bunch of trade school instructors in there, and their light went off on their head when they thought about this, because they know how many different kinds of metals are installed in a typical hydronic system, and that causes a sacrificial anode, and typically it's that ferrous material, so it starts breaking down and getting into all kinds of spots and causing issues. And then flow velocity, that's Antonia's favorite, erosion corrosion. She likes rhyming. She likes the she's a poet and didn't know it. But yeah, you can cause leaks on elbows, right, when you're flowing too much and there's debris in that system. So and then the final four ones are typical chemistry of water. Just temperature can help affect corrosion, and chloride, sulfites, and nitrates are contributors to that bacterial infection in the system. So how does air get in the system? I have makeup water here, but you could also say fill water on the initial fill of a system. You're introducing oxygen into it. And if you have leaks and you're making up water, you're bringing oxygen in every gallon you make up. And air pockets, if it's improperly purged upon the initial startup, you might have air in there. It's going to cause corrosion issues. Servicing and maintenance, I always think of my, what was it, a 2016 Edge that I had with 30,000 miles. Transmission blew up on it, had to get it replaced, and it was never the same after that. Same thing with heating systems. Once you install everything, you kind of want to keep it closed. If you start breaking stuff open and introducing more oxygen, you're just resulting in more problems. Badly positioned or malfunctioning air vents that are stuck open can actually contribute to the air, right? Can suck the air into the system. And then lower temperatures, higher pressures, talking chilled water here. When there's lower temperatures and higher pressures, there's usually more oxygen in the system. So this is the technology that we're used to seeing, right? Air and dirt removal, whether it's individual or combined. 50-year-old technology, been around for decades, but they're based around separation and not necessarily capture, and that's important to note. A lot of these have meshes in them. Some of them have Paul rings where they actually physically knock the debris down into the bottom of it. And how often do these get serviced? I don't know. I don't know many guys that service air and dirt separators. Y strainers, that's the other picture there. But oxygen is the main factor for corrosion, and it's proportional to the amount of dissolved oxygen is how much corrosion you're going to get. Again, picking on steel here because it's ferrous. With lower concentrations of oxygen, with no inhibitor, you get the corrosion that forms magnetite. If you have oxygen in your system that exceeds the rate at which you can remove it, you typically have hematite occurring, and that can cause pitting, perforation in the steel surface, and leaks. Again, making up more water, introducing more oxygen, so it's a compounding issue. And this I didn't know until I joined 80. There's 16 different kinds of iron oxides, and I'm a chemist, microbiologist guy by education, so that I thought was kind of fascinating. There's that many of them, and only one of them is magnetic, so that's interesting. And you think back to that early slide where we saw all those different samples of water from all those different hydronic systems. The one on the right is going to be magnetite, in the middle is your hematite. The one on the left looks like it's clean and clear, but that could fool you. There could be some tiny particles in there, and you're going to see here on the next couple slides of what I'm talking about. And here's a picture of some hematite, and I guarantee this is a chilled system. There's probably a lot of bio slime in there too. It looks like it, but you can see that orange color where there's still active oxidation going on in the system. And here's our favorite, the magnetite, all over the place. These are all, you'll see some backyard stuff here. This is all UK as it starts, but big time issues in these systems. This particular slide cracks me up because they have the magnets and the cartridge filters in there. So they're just wasting cartridge filters. They're just sucking up more of that magnetite with it. We always recommend to go in with the magnets first until you get the water clean, and then you start getting the non-magnetic debris with those cartridges. So, and here's the facts about it. I like this picture because it shows the pile of magnetite on the left, and then actually how small the magnetite particles can be. So when I talked about that clear water, you could have that 5-micron stuff sitting in there and not even see it with the naked eye. 6, and you're right about this, Antonia. I think the red blood cells 6 to 8 is that average size of magnetite is the size of a human red blood cell. So you imagine that, you can't see it with your eye. And some fun facts. This is my fun fact slide about magnetite. It occurs naturally in nature because it's natural. It's naturally in nature. But geologists will use it to figure out the date of certain strata of rock, because when it forms naturally, it naturally aligns with the North Pole. So they can tell how old something is by where it's deposited in the strata of the rock. And also, I went to the beach in Rhode Island and had my trusty little magnetic keychain. Is this on camera? I can't even tell if it's on there or not. Yep.
Yeah.
Don't leave home without it. I stuck it in the sand and pulled up a bunch of magnetite, and I texted it to Antonia. Well, I found out that early on in his career, Thomas Edison actually tried to mine iron, this magnetite, out of those beaches in Rhode Island. It just wasn't cost effective for him. So not everything can be the light bulb. Here's the magnetic particle sizes. So you can see that hump there is right down below 10 micron, and that is the shaded area here where the average size of magnetite is 6 to 8 microns. So again, thinking red blood cells, it's tiny and it's right there, and that's 95% of your system debris is that small. And here's a leading dirt separators chart that I pulled off. I'm not going to say who it is, but the parameters for the testing are on the right there, and you can see they do several passes. And we're guessing that they used a silica sand and not a magnetite for this test. But once you get to between 60 and 30 microns, the performance really drops off, and we're talking less than that, right? 30 to down to 6 to 8 microns is the typical size of magnetite. So this is doing its job, getting the big boulders out, I like to call them. But when it gets down to the specks of sand and the red blood cells, you need a little bit something more on your system. So again, these work well. It says up to 30 microns. I think it should say down to 30 microns.
Yeah.
Right. And the average size of magnetite, 6 to 8. So air and dirt separators are typically on the supply side of the system. And manufacturers are now starting to add a magnet to this device as a sort of check the box hat tip to 80. But again, they're relying on separation and not capture. So a lot of times these magnets will be on the bottom and they're not necessarily in the flow. I guess if there's a pressure drop there, it might work its way down, but most of that stuff's whistling straight through. And oh yeah, also important there, because we talked about the bacterial contamination. If these don't get serviced, then you have a spot for bacteria to start growing. So you want to make sure it's easy to service, and that's where we jump in with our 80 stuff. But just to wrap it up, kind of bring it full circle, air and dirt separation is vital. Every commercial system should have it and will have it. But we can acknowledge that magnetite is still an issue because the air and dirt separators are looking to separate and not necessarily capture. So you need a dedicated magnetic and non-magnetic filtration and chemical treatment in order to make a complete system protection, right? And here's why. We're used to, back in the day, the big cast iron boilers with, you could pretty much bowl inside of that fire tube, right? I mean, just, it's huge. The passageways are just very tolerant to any sort of debris in the system, but not very efficient either. So as we push for efficiencies, we start looking at the stuff on the right, or those rack systems or staged boilers, and they're typically aluminum or stainless steel, very sensitive to water quality, and their passageways are down to 8 millimeters. So we're talking big honking passageways to little tiny ones. So boiler manufacturers are starting to make note of this and pointing out in their warranties that water quality matters. It's important. And they're starting to bring those back into their CSI labs, cutting them open. And if they find magnetite, they're starting to reject warranties. So it's important to make sure you're dealing with it. And then we go to the next generation pumps, the one on the left. I still haven't seen one like that, but I know they're out there with belts and just poor efficiencies. Now we go to the ones on the right, high efficiency, again, smaller. A lot of these use magnets in them in order to run efficiently. If you think about ECM circulators, they use neodymium magnets in there too. So if you're not pulling it out with a specific device, it's chances are your pump is going to start pulling it out for you, and that's an expensive replacement. Just like this, the cost of doing nothing. School in Cheltenham, right in our backyard of our HQ, replaced twice over a 9-year period at a clip of about $20,000 each. So that pays for your 80 product if you just put it in there. And imagine how much longer this thing would have lasted had you taken care of it. And this is where we pop in here, right? This is the best practices that we came up with here in North America. This is something that we invented. And it all starts with test and then clean if it's dirty and then protect it and maintain it, because corrosion never stops, right?
Mm-hmm.
You can only slow it down, and that's what we are here to do. And here's the commercial range. Let's jump right into it. MagnaClean commercial, 2 to 8 inch flanged. This is a great product because you get first pass capture. So we're looking at applications where it's a retrofit, where you're going and designing a new boiler or chiller system into an existing building. You don't know what's in those pipes. You can flush it as much as you can. You're not repiping anything other than near boiler piping. So it's important to have something like this in your spec. And on the right, there is actually Newark Airport in New Jersey, where they were having issues and they put a 6-inch in there. So they're taking care of their problems after the fact. But really easy to service here. Again, service in mind. We were invented by a pipe fitter to begin with, so he is very aware of how things are serviced. And you can see each one of these magnetic rods pulls up. So what you would do is isolate either side of the flange. You can have a blow down ball valve on the bottom there, 1.25 NPT, and then there's an air vent up top. So pulling those rods up, crack the air vent, open the ball valve, dump everything out, and then reverse it to get it back into service. 5, 10, 15 minutes max servicing this thing.
Not only that as well, by having the rods, it means you're not breaking a seal by lifting the whole of the lid up.
Correct. Yes, those are all individually sheathed in there. So you're just pulling it up and everything's dropping to the bottom of the canister. Thank you, Antonia.
You're welcome.
The DRX, this is 2, 3, and 4 inch. This is maybe something you'd look at for a value engineering. If you're trying to bring the price down on some stuff, but still get that protection, not as much first pass protection as the rods being directly in the flow, but this is a fully capable device here. And the only one that we have that can be mounted vertically or horizontally. So those belts are spring loaded. You get 6 inches of service clearance. So if you got a tight mechanical room, you're going to want to put something like this in there. Mm-hmm. And those belts have dozens of magnets on them, depending on the size. There's more magnets on the 4-inch than the 2-inch, obviously, but there's plenty of magnets on the outside there where it captures the magnetite on the inside of the canister. And then again, servicing is as simple as the other one, the MagnaClean commercial, where you're just isolating it. There's actually a 3/4 inch drain on this one, so you can pipe up a ball valve and the air vent. So isolate, take the bands off, open the drain, open the vent, reverse everything, put it back into service. Again, 5, 10, 15 minutes max. And it's very lightweight. That I always forget to mention, because this guy is a beast. The smallest one, I think, weighs 50 pounds, and the biggest one weighs as much as a motorcycle, I think. Yeah. But this one I can lift with one arm. I don't know if Antonia could. She probably could. She works.
Yeah. The cool thing about this as well is as you go up in size, the canister doesn't get like wider. It just gets longer. So again, if you're specifying on a space restricted mechanical room, you don't need to worry about, the whole canister getting larger as you go up in size.
Awesome. Great point. Thank you. And there's a picture of just the magnets released on it. So you see there's not a lot of room needed here. And we do have thermal jackets for all our filters. So something to keep in mind.
Excuse me.
Yes.
Yes.
Yeah. How many magnets on those 2, 3, and 4 inch? How many are in that outside casing?
On the 2-inch, there's 48. On the 3-inch, 64. 4-inch, there's 80. So yeah, there's a lot of magnets.
Thank you.
Here's our newest baby, the CMX. This one is getting very popular when guys start seeing it and understanding what it does. Magnetic and non-magnetic debris removal. You can see the Nano on the left here, and I'll use my cursor now. This actually has available to it an optional thermal jacket that has magnets inside of it, so more than doubles the capture of the magnetite with this one. And you can put a cartridge, one single cartridge, in the Nano. And I'll show you where I think this would be a good fit, again, on a value engineering option. The MIDI, very capable, you got three cartridges in there. And the Maxi is a bag filter. So no cartridges in this one, and it has a stainless steel strainer. These two can be used as chemical dosing pots. So that you'll see a little bit later on is very important. And here's a X-ray vision view of it. And I'll read this eye chart for you if you can't see it, because what we have here is gallon capacity based off of the flow rate on these. And we put these and we size them based on a 24-hour period with 4 passes through the filter. Whoops, 4 passes through the filter. So that's how we come up with that 85,000 gallon capacity. So looking at big jobs here, although guys are putting these on smaller jobs just because they like the dosing capability of it. Where to install, we got a picture of a MagnaClean commercial up on the top here, and it shows a chiller system. You got that on the supply side for chiller. You're going return for boilers. This one shows what I would call like a plate and flame heat exchanger, plate and frame heat exchanger, not plate and flame, but plate and frame. So you're protecting both the boiler and this side of the heat exchanger, and then you're protecting the system and this side of the heat exchanger with this. And that's shown in a side stream. We'll go over that a little bit the next slide, I think. But I wanted to touch on this one because this is a great application on steam condensate return. We've got a lot of these in the Midwest at manufacturing facilities that use process steam, and they're just filtering their return water right before the condensate receiver here, which protects the pumps on the condensate receiver. If you think about it, all that debris coming in that's magnetic, we can pick it up beforehand. And here we go with the side stream. So the benefits of it: you can use a smaller filter, competitively priced filters based on this. So rather going in line, you're going around the pump. We'll show that on the next slide here. But great in a retrofit to replace a chemical shot feeder that's already installed is a good option. And that's where I've been pushing it on big commercial and manufacturing jobs. And also the Nano is very compact. You'll see some pictures here shortly where you can pretty much fit that thing anywhere. And tool-free servicing. I didn't mention this, and that's pretty much across the board for our filters. Rather, for the residential, we do have a little spanner wrench, a little time, but you can even do hand tight on that, and I think be safe because you're only talking 12 to 16 psi, right? But again, minimal water wastage when you're servicing these, and if you do go in a side stream, there's no downtime. Time is money for manufacturing facilities, and I think of applications where heat and cooling is critical, like a hospital or dormitory. Those sort of applications we're targeting with this with good success. And another one, yep. If the filter gets blocked, you're not shutting down your system, right? It's just going to bypass it and continue on through, but you're not going to be capturing any more stuff, right? You're not going through the filter, and it can again lead to another bacterial colonization point. So important to service these, just as important as it is to install them, right? And here's another picture, a little bit more in depth, showing where to install this with the filter outlet on the suction side of the pump. So you're going across it, creating that differential pressure and forcing a portion of this water to go through each time it goes through the pump. The other option is to go on the flow and the return, because you're still getting differential pressure through there. So these are some options for side streaming. And here is some looks. I like this one on the left because they actually have a dedicated pump for this Nano here with a little pressure gauge, so they can see when it's plugged up and when it needs to be serviced. This one's up in a ceiling, so it's out of the way. Again, just showing you the flexibility of the Nano. And each one of the heating circuits in this building has its own dedicated Nano. More Nano pictures. I like the middle one here. That's a rooftop chiller. Just putting it right in there with it. And then this one really shows how compact it gets, and you can put it in that little tiny area right there and get your system protection.
And that's got the magnetic jacket on, right?
It does, yeah. The only thing I'd be worried about is maybe service clearance. I can't tell down here, but I think they probably thought about that beforehand. And more side stream installation pictures. All right, that's enough of those. And if you think back of the schools in London that I showed you, all those different water samples, this was one of them. This is a chilled system at this Lister High School. And that's after 6 hours with no cleaner. That's just straight water on the chilled system going through there. And if you see there's the metal strainer for the Maxi right here. This is the Maxi because it has 4 rods and there's the metal strainer. There's so much slime and sludge and non-magnetic material in that bag that the water's not even pouring out of it. So that I thought was pretty impressive. But I want to touch on North America because that's where we are. And this was a job I went to up at SUNY Albany, State University of New York in Albany. They have these ugly, at least replace it with a stainless steel container so it's pretty. But this is an old chemical shot feeder with these socks, right? These sock filters that go in there. The funny thing is I have a video and I didn't put it on here. That sock is completely magnetic now. You can pick it up with a magnet because it's 5 micron and there's still stuff going through it. This is another job just outside of Albany with that chemical shot feeder. And there's my my little rapid test stick on my keychain that I showed you. That was after this filter, after this sock, we pulled some water off and I was still able to pick up that much magnetite in it. So these guys are putting a CMX MIDI in. These guys are going to put a Maxi in. But here's where I was talking about with that value engineering. You know, if they don't want to go full on replacing their chemical pot feeder, or if you're specifying one and you still wanted magnetic protection on it, that's where the Nano would fit in. You can pipe it right in line with this thing. So you got your magnetic filtration, your dose pot here, and your non-magnetic filtration. So all kinds of options. And again, there's that rid lime again. More rid lime. I want to be that salesman. Start selling rid lime. More side stream installation here. This one, we like this guy, right? We're going to name a holiday after him because he's got 2 midis, 2 maxis, and a commercial filter on this system. Good job. And here's another one in my backyard. These are actually oil-fired boilers. You can see the supply and return oil lines on here going to each one of these. Not sure what the manufacturer was because these guys were not having issues with their boiler. It's probably a big sectional cast iron. What they were having problems with were all the pumps you see here. Pump here, pump here, pump here, 2 pumps here. They were failing left and right. So this engineer actually put in where he's going to put his CMX side stream filter across the supply and return right next to the pumps there and get that magnetite out of the system. And that's what it looked like. After he cut it in there, after 10 minutes of runtime, look at all that. This is after a day. No cleaner, no bag filter, just the magnets and the water going through in a side stream. So very effective, and seeing is believing, we like to say. So you can show this to a building owner and say, this is how we're protecting your system. And I need to mention our chemicals because they're just as important as our filters. What we have available in North America right now is MC1 is our protector and MC3, which is our cleaner. And something that we offer that other chemical manufacturers do not is what we call compensation chemistry, where the cleaner has a little bit of inhibitor in it. So it can stay in a system up to 28 days. And if it starts uncovering and leaving bare metal behind, it'll actually apply a little bit of inhibitor there until you drain it down, fill it back up, and put your inhibitor in, which has a little bit of compensation chemistry to be able to neutralize up to 20% of the cleaner out. So you don't have to have everything completely purged out. You get as much as you want, or as much as you can. You'll still be able to neutralize 20% of the cleaner left over. Now, one I'd like to test over here, which is specifically made for the CMX, is the MC35 leave-in or no drain cleaner. So you can leave it in there and just continually cleans the system. Biocide we don't have available here yet. I'd love to see it, but I wanted to bring it up because we had so many slides on the effects of bacteria in your system. So please make sure you're specifying some sort of a biocide. And antifreeze just doesn't make sense financially for us to bring over here, but this is inhibited antifreeze, our MC0 plus. You can add MC1 plus to just about any antifreeze glycol out there, including ethanol. So I wanted to mention that.
I also advise, if you are going to specify a biocide for the system, pair it up with the inhibitor, the MC1 as well.
And we have sizing calculators, dosing calculators, so that's available to everybody. And we're here to help, right?
Yeah.
That's it. How'd we do? Ooh, I went a little bit over. Sorry,
That's
everybody.
okay. We started a little late.
Okay. And we didn't lose anyone. Excellent.
Yeah, fab. So everybody it can talk on here. So if you do have any questions, feel free to shout out or type them in the box. Me and Jamie will hold on for another few minutes, maybe 5 minutes. So yeah, if you have got any questions, just fire away.